Last time we talked about sedimentary minerals and how sedimentary minerals are formed. Now we're going to talk about sediment itself, right? The little grains, the little bits and pieces of sedimentary rock, of sedimentary minerals that can move around our planet, forming resources that are very important to us as humans. So let's go ahead. I will share my screen and to get going. So we're going to be talking about the formation, the transport, and the lithification of sediment. Now, just to set the stage for sedimentary processes, right? Sedimentary rocks, sedimentary minerals, sedimentary processes create environments like this, where there are these beautiful bands of color, beautiful bands of different types of sediment that were laid down over long periods of time, and now preserve the record of the formation of that land, almost like pages of a history book. Right? Here's another example of that beautiful progression of history preserved in the sedimentary record here. Here's another one, the White Cliffs of Dover preserve the warm, high sea level of the Cretaceous. And not only do they preserve evidence of how this area was created, the temperature, the sea level, the atmospheric chemistry, things like that were present at the time of the formation of the sediment, it also shows history of erosion, right? The weathering processes. How did the environment change after the sedimentary rock was created? That is also preserved here in this beautiful erosional weathering feature. All right, so let's talk about the importance of sediments and understanding the history of the Earth. As I said, sedimentary deposits are like pages of a history book. They preserve a record of the past. And that's because sedimentary rocks are formed by the accumulation and burial of sediments and depositional basins. So these depositional basins are basically just these low elevation pockets that take in bit by bit, grain by grain, evidence of what the environment is like around that basin. Sediment is formed, most sediment is formed from weathering of pre-existing rocks, like we talked about the last time when we talked about weathering. And this weathering can be due to physical, chemical, or biological processes. Right? So each tiny little grain of sediment, almost like the letters of the words that make up the history books, each little grain is formed from weathering of pre-existing rock. Right? That sediment then has to be transported from its source to its depositional area. This transport often goes downhill and is facilitated by water like rivers, wind, ice, gravity, things like that. And we know that water doesn't only carry the solid grains of sediment, it also carries the dissolved ions in solution down towards the ocean. And during the transport, these sedimentary particles tend to separate based on their size and density. They sort themselves out along this depositional pathway. Now, once that sediment is deposited, it's going to be deposited based on topographic relief, right? It's going to settle in a local low elevation area like a lake, like a floodplain, like the ocean. And these low elevation areas are often produced by plate tectonic processes. So a lot of sediment tends to be accumulated near certain plate tectonic boundaries. And high relief at convergent and divergent plate boundaries promotes a lot of weathering, transport of sediment away from these areas until that sediment ends up in these low-lying regions, these depositional basins. Right? Once that sediment is deposited in those low-lying depositional basins, then that sediment can accumulate, be buried under more and more sediment, and through that, it's going to be put under a lot of pressure, compacted. Water might be circulating through the pore spaces, causing deposition of a natural cement or maybe causing recrystallization. And over time, these discrete individual sediment particles are going to be lithified into a single sedimentary rock. So lithification just means the formation of a rock, a sedimentary rock specifically. And this is why we can interpret sedimentary rocks, right? Because each individual grain holds evidence of its source, its transport, the environment that it was deposited in. We can read that grain just like the letter of a word of a page of a history book. So in this lecture, we're going to be examining the history of sediment from its source to its final site of accumulation, and then eventually its conversion into a sedimentary rock, its lithification. And the process of weathering and sediment transport can lead to major redistributions of elements in their crust. Right? This is one of the reasons why Earth is so unique, is because of all of these surficial processes that create new minerals and cause minerals to sort themselves out and be concentrated in some areas. So the resulting sedimentary rocks are therefore of great importance in adding to the diversity of Earth's minerals.